Hello guys, welcome back to my channel Algorithm Minds. My name is Hassan Khoram and in this channel I teach programming skills in Python, MATLAB and R programming. I also teach Tableau, a data visualization tool. So for today's tutorial I'm going to teach you how we can actually use this function Euler in MATLAB and calculate the Euler of numbers and polynomials. Okay, so that being said, we can actually calculate the Euler of even numbers and we can calculate the Euler of odd numbers. So the Euler numbers with even indices alternate the signs. Any Euler number with an odd index is 0. Okay, so first of all we are going to compute the even index Euler numbers with indices from 0 to 10. So if we are calling the function Euler and we are within the input argument, within the bracket we are passing the input argument in the form of array. So here 0 colon 2 colon 10 is actually an array that starts with 0 and with an interval of 2 from 0 to 4 6 8 and finally it reaches 10, so it will have 5 set of values. So we'll calculate the Euler of 5 values that are even, and in the same way we will calculate the Euler of 5 values that are odd. So in order to create odd values we will start with 1 and end at 11 with an interval of 2. So let me just run this block of code for you. So now you can see that we have Euler values for even numbers and we have Euler values for odd number is 0 0 0. But the beauty of this function is such that we can also calculate the Euler of polynomial. So in that case the Euler will take two input argument. You will be able to better visualize it in the upcoming topic in this video, so I suggest you to stay tuned with this video. So we have called the Euler function and we have passed two input arguments 2 comma 1 by 3 and we get the value of minus 0.222. Okay, now we would like to compute the first, second and third polynomial in variables x, y, z respectively. So in order to better visualize the Euler operator, what we are going to do, we are going to create symbolic variables and then implement the Euler function on symbolic variables. So first of all we have, in order to introduce symbolic variable, we use this statement syms. Then after that we will declare the variable names x, y, z. Once we done that, we will call Euler function and we will pass through input argument we like first polynomial comma x. Okay, so in that way we get the answer x minus 1 by 2 and would like to calculate the second polynomial Euler of y. Okay, so here we have 2 comma y. In that case the resultant is y square minus y. Okay, in the same way we will calculate the third polynomial Euler of z. So we have like 3 comma z. So we have z cube minus 3 by 2 z square plus 1 by 4. That being said, let's move on and actually plot those values. Okay, so in order to plot an equation, this is basically an equation. Okay, so this like 1 by x minus 1 by 2 y square minus y. So these are the equations. Okay, symbolic equations, and in order to plot symbolic equations we use fplot function. Okay, so we have like syms x, so x is declared as a variable. Then we will calculate the Euler of x and here we are passing 0 to 5, so it will start with 0. So 0 means 0 polynomial and it will increase by 1 value, so it will calculate the Euler of with respect to first polynomial, second polynomial, third up to the very fifth polynomial. Okay, and here we are defining the range of those functions. So whatever that value might be calculated, for example we have x minus 1 by 2, so it will put like value of 1 as a lower limit and it will put the value of 2 in the x as an upper limit. So that being said, then finally we will plot the title by use of this function title Euler polynomials. Then we will set the grid odds. So this is what it actually looks like. So like the Euler of x that will started from 0 up to the very 5 1. Okay, so for 0 you can suggest that this is the line, and for Euler 1 we have like minus 1 to 1.5. So that's how you can actually implement. Finally, we can also use many functions such as diff and expand that can handle Euler functions. Okay, so here we have first of again form symbolic variables n and x, and here we are creating an Euler function with n polynomial, and the x is actually x power 2, and this is the Euler function, and then we are derivating that Euler function with respect to x. So now you can see that it has successfully applied the derivative on that Euler function. So that's it for today's tutorial. I hope this tutorial have been helpful. If you have any question regarding today's tutorial, feel free to write down your comments. I will be happy to help you out. Thank you for joining me, and I will catch you soon in the next video.